this section, we'll look again at those improper fractions. Another way of writing an improper fraction is to write it as a mixed number. So we'll look back at this picture. Remember, we did this picture before, and we said each circle was cut into 6 pieces, so our denominator is 6, and there's 7 of those pieces shaded, so the top number is 7. That's an improper fraction representing the shaded area. But we can also write this as a mixed number. We have one whole circle that's shaded, so we could write a big number 1. And then in the second circle, we have 1 out of 6 pieces shaded. So 1 and 1/6 represents a mixed number. Mixed numbers have a whole number in the front and a fraction, proper fraction, put together. So to change an improper fraction to a whole number, we need to figure out how many wholes, how many times the denominator divides into the numerator. The remainder of that division is the number of extra pieces, so we write that as a fraction. And remember, we did remainders in Module 1, so you can go back to page 10 if you need other examples. So if we look at this, we have 36 pieces that are shaded, and each whole is broken into 28 pieces. So we need to see how many wholes we have first. So we'll take 36, and we'll divide it by 28, and we get 1 with some extra decimal stuff left over. So we'll take 1 times 28, get 28, and subtract, and we get 8 left over. So this is telling us that there's one whole circle, or one whole pie, filled in, and then 8 pieces out of the 28 left over, shaded. So we're going to reduce this because our answer needs to be simplified. Divide by 2, and we get 1 and 4/14. But that can be reduced again. We'll divide by 2, so we get 1 and 2/7 for our mixed number. So to go the other way, to change a mixed number into an improper fraction, remember the number in front tells you how many wholes, and the denominator tells you how many pieces are in each whole. So if we multiply those together, we find out how many pieces we have completely. Then the top of the fraction is the extra pieces, so we have to add those into that number. The size of the pieces stay the same, so the denominator stays the same. So this is telling us that we have 8 full circles. Each circle is broken up into 6 pieces. So if we take 8 times 6, we have 48 pieces in those 8 circles. Now this 1 on top means we have 1 extra piece, so we take 48 plus 1, and that tells us we have 49 pieces total. But those 49 pieces are still, those size of those pieces are the sixths, so we have to say we have 49 sixths. So this is the same idea. We're going to ignore the negative first. We're going to take that 1 times that 5, because it's one whole broken into 5 pieces. And then this tells us we have 3 extra pieces, so we'll take that and add to it. So we have 8 pieces total. And those pieces are fifths, so we keep the 5 on the bottom. And that negative that was out in front, we just keep it out in front. To multiply or divide mixed numbers, you must first change them into improper fractions. Pay attention to the instructions that are in parentheses. This tells you how they want the answers to be entered. So here we have negative 8 4/7 times 8 1/6. It tells us to simplify our answer and then write an integer, proper fraction, or mixed number, okay, as our final answer. Now we can't multiply these the way it's written. We have to change it to an improper fraction first. So we take 7 times 8, which is 56, And then we add those extra pieces on top. So we have 56 plus 4, which gives us 60 over 7. Keep the negative out in front. We'll do the same thing with this other fraction. We take 6 times 8, which is 48. And then we take that 48 and we add that extra piece on top, which is 49. So we have 49/6. Okay, and now we're going to multiply, but I'm going to do some simplifying first. These can both be divided by 6. So that leaves me with a 10 on top in my first fraction and a 1 on the bottom in the second fraction. These can both be divided by 7. That leaves me a 1 here and a 7 here. There's still this negative, still the multiplication. So I multiply straight across and I get 70, negative, and then 1. And negative 70 over 1 is just negative 70. So here's another problem. We have 3 1/7, negative 3 1/7 divided by negative 2 3/14. So first we need to change those to improper fractions. So in the first fraction, we'll take 3 times 7, which gives us 21 pieces. Add that 1 extra piece, and we get 22 pieces. So we're going to rewrite our first fraction as negative 22 over 7. Then we'll do the same thing for the next fraction. We'll take 2 times 14, which is 28. And then we'll add the other 3 pieces on top, which gives us 31. Keep the negative. So we have negative 31 over 14. Now remember, when we divide, we keep the first fraction, we change division to multiplication, and we flip the second fraction. Keep it, change it, flip it. Multiply by the reciprocal. And now we can do some simplifying here. We can divide those both by 7. So it leaves me with a 1 on the bottom in the first fraction and a 2 on the top in the second fraction. I don't think anything goes into 22 and 31, so I'm going to just have to copy those. I'll multiply straight across. Negative 22 times a negative 2 is positive 44 over 31. Now it tells us that we want to write our answer as an integer, proper fraction, or mixed number. Now this is not an integer. An integer just means like a regular number. It's not a proper fraction. It's improper. So we need to write that as a mixed number. So we need to ask ourselves, how many times does 31 go into 44? It goes in 1 time, so we take 1 times 31, and we subtract, and we get 13 left over. So that's our new numerator, 13 over 31. That's our final answer. Okay, so let's look at this with addition. With addition, you do not have to change your answers to an improper fraction. Let's try this without changing. We have negative 5 3/8 plus 2 1/2. I do have to have a common denominator. So my common denominator here actually is 8. I can just multiply this fraction by 4 over 4 to get an 8 on the bottom. So I can rewrite this as negative 5 3/8 plus 2 4/8. Okay? So if we think back to our rules with signed numbers, positive and negative numbers, we have different signs, which means we actually have to subtract 5 3/8 minus 2 4/8. Now we can't do 3/8 minus 4/8 because we don't have enough there. So we're going to have to borrow 1 from here, and that adds 8 more pieces to this. So this is like, this now has 8, 9, 10, 11 pieces. We're taking away 1 whole circle, adding 8 more pieces. We have 4 11/8. So now we can subtract. 4 minus 2 is 2. 11 eighths minus 4 eighths is 7 eighths. So we have 2 and 7 eighths. The bigger number was negative, so our answer is negative. Now this is a pretty complicated problem. Let's look at it maybe in a little bit easier way. We don't have to change it to an improper fraction, but a lot of times it's easier. So let's do that first here. So we're going to take, in our first fraction, we're going to take 5 times 8, which is 40. Add that top number, so we get 43. So we have negative 43 eighths plus, and we'll do the same thing for the second one. 2 times 2 is 4, and 4 plus 1 is 5. So we have 5 over 2. We still need a common denominator, so I'm going to multiply the top and the bottom here by 4. So now I have negative 43 eighths plus 20 over 8. Different signs, so I need to subtract, which gives me 23, but the bigger number was negative, so I have negative 23 eighths. Now again, the directions say integer, which is just a plain old number. This is not that. Proper fraction. I have an improper fraction, so that doesn't work. Or a mixed number. So I need to change this to a mixed number. So I'm going to see how many times does 8 go into 23. It goes in 2 times. So that's my big number in front. It is negative, so this stays in front as a negative. 2 times 8 is 16, so I'll subtract 16, and that leaves me with 7, so I have 7 eighths. Negative 2 and 7 eighths, the same answer. So that should help you do that section.